Afternoon. First session after the keynote, so I hope that everybody's still awake. No, not really. Okay, let's see what we can do about that. So this is Johan. He is from our partner Youmoni. He's going to do the whole technical talk, and I'm guiding a little bit, doing a little bit of introduction and an outroduction. Is that a really word?
Yeah.
I really don't know, but. Tell you a little bit of the next steps of then what we see for Youmoni to go to. And yeah, let's have a great time, I guess. And my name is Jeroen Bloem, of course. I am a solution architect for the Benelux region, so I stepped in for a colleague of mine. So let's go. So the agenda, we did some introductions already. We're gonna define the edge a little bit, have a little bit of an introduction. What is the edge? What do we see as the edge, what we're doing in it. Johan is going to present the Youmoni IoT platform with a live demo. We actually got it working over there. And then the final part is SUSE Edge 3.0 at high level overview. By the way, we stated question and answer in the end, but if you have a question, just raise your hand and we're going to give you a mic, especially because that is more interactive and we like it both that way better. So defining the edge. So what is the definition of the edge? Can somebody help me here? There's no wrong answer, right? It's
data outside the data center.
Yeah, it is data out of but it's more than that.
Of course.
It is, so a definition. Edge computing is a distributed information technology architecture in which the client data is processed at the... basically what it means is we process the data as close to the human being or the client as possible. You wouldn't be driving in a car, you wouldn't like it to drive in a car, for example, and it sees a red light and then it has to talk to the cloud to say, hey, I see a red light, what do we have to do? And before you got an answer back, you're driving through it, causing an accident. So you need to have data being processed at the edge. It has a couple of advantages, quicker response, but also you only have to send out the monitoring stuff or the parts that you want to send over the line to a central place. So what happens at the edge? Well, basically that data processing is happening at the edge. That is the most important thing that you need to remember, what the edge definition is, that it happens at the edge and not in a cloud or whatever. So we got a near edge, far edge, and a tiny edge. So the near edge, what we talk about is it's 1 to 100 devices. It's very close to the data center. Where it's becoming more interesting is the far edge. For example, there are right now satellites in orbit running K3S. Yeah, that's really, at this moment, the ultimate edge for us, at least, for SUSE. We don't have yet a Mars robot or something, so it's still the satellite, but that's the farthest away. But the next thing is that tiny edge is very interesting, and that is where we are growing towards to. So more and more industrial IoT is getting interesting what we can do there, but it's massive. And that is where Johan is going to take us a little bit further into that overview and what Youmoni has created.
Yeah.
So,
thank you.
Up to you.
Thank you. So my name is Johan Edgren. I'm from Youmoni, and we're located in Stockholm, Sweden. And we have developed an end-to-end IoT platform and also collaborate with SUSE to make it a SUSE Youmoni IoT platform that take advantage of both the infrastructure. We're working with all the cloud platform and all the edge, far edge and tiny edge as well. So I will walk you through a little bit about this common initiative and also with some customer reference and so forth. But how it all started is actually that we discovered together that we had a ready-to-use, cloud-ready and container-ready IoT platform that was developed here in Europe. We have all the software stack. We're not depending on AWS or Azure or anything or other IoT concepts. So everything is within the Youmoni platform. And a lot of customers started to ask, could we have like our own infrastructure, own all of the data that we have, our sensor data? It's sensitive in cities for defense. Larger industries doesn't want the data to be processed elsewhere. And could you make that happen? And together with SUSE infrastructure and edge computing and Rancher combined, it's a ready-to-use IoT platform with all layers except for bare metal for running things, but everything else is actually there to be able to use today. Even with the end-to-end concept of actually being able to connect things, and to the left here, what we define as things is that we have actually ready-to-use edge applications and gateways and trackers for logistics, for like machines, properties, and even tracking like human beings for different purposes. We also embed into the offering ready-to-use connectivity. So we work with worldwide connectivity providers for 4G and 5G in Europe and the US and in Asia. So we can actually provision that end-to-end and provide security also in the mobile network layer. And the Youmoni cloud is about where we store, of course, monitor and control devices, but also execute business rules that is from the cloud, but also business rules that can actually affect the edge, that the edge get new instructions over how to process data depending on business rules that the cloud has discovered. What I think is inspiring today with the SUSE AI initiative as well, that we have had the same philosophy. So we're running today TensorFlow on-prem to actually process sensor data within our cloud, so we can actually ensure for customers that their machine learning and so forth are not sent away. It's actually processed locally. And then we have ready-to-use apps. So we have a complete set of user interfaces with mapping, with user control, user administration, asset administration, device administration, and everything in the back end. It's based on React technology, so it can be used in browsers or in iPads, and it's, of course, a responsive design of that. And it can easily customize for partners or for customers. It's a white labeled solution, so everything can be branded. We also have a structure of have a customer of customer in the system. So it's a multi-tenant cloud environment. So you can provision different customer in the same environment. But you can also, if you have a customer that has a partner, we also have that access level, security level, and also filtering of data level. So if you want to start an IoT initiative and just want customers to have their domain, look at their things, have their service technicians, have their data, it's also possible to do. One deeper level down, we actually, of course, then have in between here selected some hardware, but we also provide actually our own hardware where we think it's missed on the market. But on these gateways and trackers, on some of them we call the far edge, we actually run SUSE SLE Micro. So the SUSE SLE Micro and the edge computer are here, and then connects also to the tiny edge where we have sensors, but also some tiny edge cards. You can see one of them there. I have a picture of it, but it's called Youmoni Sense. It's actually a Sense as a server technician, but we provided it in hardware. So we work with tiny edge and the edge. Our cloud then also have REST APIs to be able to do standardized or customized apps. So you can have end consumer apps connected to our cloud, but also service technician apps and business processes related to sensor data. We also have payment systems, so an end consumer could pay for something and then get access in the physical world. For example, if you want to open a door to a toilet, you have Apple Pay 1 cent or 10 cents. Our system, you do the transaction, then affects the far edge and opens the door. That's typical use cases that we can do, actually only configure within the platform. In the business integration layer, we have integrated platforms like Make and other also cloud integration platforms. So it's quite easy to integrate data and data sets from external systems if you want to this platform. Typically, what we say, if a customer has an ERP system or an asset management system, an ERP system, asset management systems are very good of storing what you have. Assets, serial number, products, where they're located, addresses, customers, everything. So you have an asset number. What we do is sync that asset structure into our Youmoni cloud, because we have divided assets from devices and edge. So we have divided business from edge and IoT computing. So when we slave an asset repository, we can add devices to the assets within the business. And then when we hook them together, it becomes a digital twin in our platform. So we can also loosely couple the devices and far edge, but couple it to an asset that is the business object. So we're very good at the technical aspect and then the business aspect, and then we can do business rules related to this. So typically asset integration. So if you put this together with SUSE, it's the combination is a secure, scalable IoT platform. SUSE brings to the table infrastructure, SLAs, SLA micro, storage, infrastructure, and on the bottom, container management, deployment, and provisioning. If we put in our systems, it's back-end IoT services, it's our end-to-end application stack. We have everything microservice oriented, can be run in containers. And then the end user and business users, they get their business interfaces, IoT dashboards, end user apps, and ready-to-go solutions. So this can be provided out more or less out of the box today. And we have prepared like an AWS template to be able to spin up the stack to make it like a trial system. Some of our customer examples, I will walk you through a little bit of the use cases just to understand what's possible to accomplish. To the left here is one of the largest European boat manufacturers. I think they're the third. They're from Sweden. They're called Nimbus. They're making premium boats for Europe, US, and Asian market. They sell about a couple of thousands of boats each year. They have decided to use our far edge, our cloud, and our app system to actually make a boat a Tesla car. So in the car, they use our far edge computing to put it into the boat. We hook it up to the network. It's called an EMEA network in the boat. We add on sensors. We listen to the engine. We listen to vibration sensors. We sense how the boat is feeling. Also analyze the drive mode for sustainability. A lot of energy is going on in boating. It's like 10 more times fuel than the car. But if you can adjust some things when you learn with sensors, it's really good. And the end consumer, they get an app, like your Audi or Tesla app, but it is a Nimbus app, but uses Youmoni app infrastructure that connects to our cloud. So the boat owner gets everything in their app, the location, weather information, and that's actually where the boat are. You want to know how your boat are when you're in town and the boat are 2 hours away. And it sensor data from the engine and alerts and so forth. So that's one quite large project that we have accomplished. On the middle here, it's more industrial. It's like our customer, they make purifiers of water for offices, for gyms, and everything. They used to be an offline company, so they just sell the product, and then they needed to support, make service, maintenance, change filters, but they didn't know. So, okay, let's do it for sure. Okay, we go there every 4 months and change filter, and we think everyone is happy. But today we have put in water quality sensors, pressure sensors for filter, leakage sensor to be able to find out proactively if there's any problem with the machine. The machine communicates to the cloud. The cloud also provisions service technicians with alerts, but also the dealers so they can see the status of all machine. it actually gives them a business possibility to do upsales. But because they can say, oh, we can see you used your machine a lot. You need to change filters maybe in 3 months. We can pre-order it for you, so you have them when you need to switch. And then when the customer needs to switch them, they only get the notification. Now you could switch your filter. So they have saved their own service organization time and money. They have upsold a filter, and the end consumer and the customer are more happy about the product. So that's like IoT in a nutshell when it's actually used in making services processes more efficient. And what we're doing now is actually also launching end consumer apps you can buy for water, because then the gyms, the customer can establish new possibilities to sell water instead of just give it away. So that's cool. Danfo, it's a Swedish company. They actually doing official toilets. We've been, when we do installations, there's always a lottery who should go to the toilet today and check the technology. It's not that fancy, but it's a really, really good use case. So we actually made these toilets online, both for security reasons, controlling the doors, is anyone locked in? How about the air is very for smell and stuff, controlling the air pollution, and also monitoring the fans and also the water, because it's a Swedish one, for sustainability, actually reusing water. Not for drinking, but water for the flushing and stuff. So we're also measuring the sustainability, the turnaround on the water and how much you can use it and control everything, and they can see everything from the cloud. They actually pre-manufacture these houses, very modern. So you, as a end customer, you just order 10 more official toilets, and everything is mounted in Sweden, and it comes ready to use and deployed. Very popular in the UK, Sweden, Germany, and also a lot in the Middle East. So it's a big provider. So what is IoT then on the edge? What do we do? Actually, far edge, we use a lot of industrial Raspberry Pi computers. This is a German one from Kontron, very good. We call it a BMW, of course. It's very, very robust and very good to use. You can see it there running. It's also deployed in the toilets. So we run their Linux containers and the edge logic. But it's also connected to the Tiny Edge. And here you can see our own Tiny Edge. It's a Youmoni Sense card. We are actually trying to make a service technician sense in hardware and with AI. So this card has radar, microphone, temperature, humidity, and vibration sensors. And that's how to make hardware and AI of a service technician, because what do? They listen, okay, yeah, the crankshaft, it's broken, I can hear that. I can feel the vibration. And actually the ball bearing is hot. That's what they do. So what we have done is that you can add on these cards. It can communicate with the far edge using either Wi-Fi, RS232, old school, but also CAN bus. So you can distribute the Tiny Edge to a far edge, and it senses machines and things going on. And then we can analyze the sensor data and learn what is a normal pattern. And if the normal pattern changes over time or very disruptively, the cloud will know that and alert things. Okay, we need to check this out. Something is happening. It's not normal. So that's what we do. I also want to show you this picture in our own. It's actually the Youmoni production facility, because we actually do pilots where we do our own production. And this is what IoT is about. Often we talk a lot about edge computing, software, scalability, but no project scales without boxes. That's why it's only becomes a small proof of concept with 2 hardware units, and then nobody, who should do this, who should mount this, who should build this. So we do this we have actually both our programming office and then we have our lab office with 3D printers. This is students from the Royal Technology in Stockholm. So we hire them, and then we also know is the best personnel to hire later on. But they do our pre-production, test our technology, do the latest hacking, but then they need to practice to build things so it actually works. So if you do projects with us, we can do both the software side and make pilots work. Of course, when it's thousands later on, we do the drawings for outsourced production. But that's how we can do very quick turnaround and really test how IoT should work and be both sustainable but also possible to build in a business efficient way. You need to tune both the hardware, the software within the boxes, and then the processes. It's how we work. So you can see the things here. It's like the far edge. It's running here, this computer with a container. And you have our sensor card here. The Youmoni Sense is communicating here. And then some other typical standard industrial sensors that we have just made a demo so we can show that we can use both traditional analog things, digital things, and then process it together on the far edge.
Feel free after the talk to come over and watch.
Yeah, sure.
Yeah, break it.
Break
yeah,
it.
well, that.
Yeah, probably I've said most of this, but yeah, it's the control in the toilet, not in all four of them, but it's somewhere there. And we then run SUSE SLA Micro, the K3S container, and the Youmoni Edge software. So in this case, we have an edge platform that we work with. We have written that in Java. It's a little bit more heavy than in the tiny edge, where we use more C programs and free RTOS, very, very complex, more what do you call it, minimum size of code footprint. But this one can do more complex things. Yeah, remote monitoring, access control, and actually also point of sales it's prepared for, because the location of a public toilet is often in the central of a city. You could sell a lot of things there, like sun cream or suntan, so we plan for the automatic sales. And we've done that to other retailers, but we do putting that on the far edge now, because we have both the transaction possibilities and actually to like open locks and open also like hatches where you can get your things that you have bought. So in a nutshell, what Dan forgets, to the right you can see that they have a Youmoni console. It's their dashboard for all their toilets. It's branded with their logos and stuff. They connect to our cloud. Then we have the Contron device that actually uses 4G. You have there as well the 4G modem that's connected to the Contron. Here we run the software, and to the Contron via both CAN bus and other buses, we have sensors and tiny edge hardware cards. We also communicate with their lock controller over RS-232, so it's an old one, but then we communicate that on the edge and have the business logic running on the Contron, how to communicate with the lock controller, and then the Contron works with our cloud. And then they also have some Modbus data. I don't know if you're familiar, but Modbus is typically for facilities and properties. It's everywhere, it's analog. And we have made software to connect to Modbus, often called Modbus RTU. It's like for heat controllers and air conditioners, or in this case lock controllers and whatever. Switching it can be as well. So that's the use case there. So the tech layers that we are outlining here together with SUSE, if you do it they're running our public cloud, but if you're doing a private setup with all the infrastructure from SUSE, we can see that on the edge computing here, we have, as you saw, our edge computer, connect sensors, use SLE Micro. We have actually K3S now. We can also run Podman, but the container here. We have our edge with Cura, and it's running Java and Scala code, and then we have our application layer, depending on what we should do on the edge. On the cloud side, or the central side, we have the Rancher is to make both the possibility to monitor and update the containers, but also run our platform containers in Kubernetes here. And then all containers have services with REST APIs, and of course our own user interfaces uses our own APIs, but then you can also do other custom APIs or custom applications to the platform stack. Running on SUSE Linux Enterprise, and then also be able to use the long-haul redundant storage, because we actually store 3 different data sets. We store, of course, SQL data, but that's a lot of JSON data because we're data-driven in the platform. It's quite modern, so we store JSON objects. We do that in a Postgres database, so we can also search in JSON objects. And then we have, for block storage, we have all the images, we have binaries, we have firmwares and stuff like that we need to store. We do that separately. And then we have time series data for all the sensor data that's just flowing into the platform. We need to cope with all the time series and search in them. And we use Influx for that. So our services combine these data sets when it presents things in our APIs. It's how we can cope with performance and also use the most optimal storage media for each different data set. Now I'm going to one more technical layer. Some it's more technical, and you can ask me anything, but just to show how such a platform is actually working in the cloud environment. One of the things with Edge that difference it's from other platforms, it's that you always have a data flow that is from machines and things. So you need to have a separate path of that data. So to the left here, we talk in from trucks or gateways or computers. We talk either HTTPS, but mostly MQTTS. That's an IoT protocol. It's TCP based, so it's very lightweight and very fast. We use that a lot. We also have the possibility only to listen to packages, small packages of TCP, even UDP packages, and listen to them for like position updates, tracking updates. So then we have, of course, a firewall and a port filtering layer. We have an authentication layer. And then we have an MQTTS and TCP broker layer to be able to have all the data that's coming in to a broker. And that's just first when it comes to our microservices. So that's one path into the platform. The end user path is, of course, through load balancing, but then it's also it's more secure and isolated with proxy servers. When it goes through proxy services, it goes to authentication layer and get a JWT token. And from an external source, in this case, is auth0. Then it comes to our REST JSON APIs that the token is verified to make it very secure. Then we actually switch the token to an internal token. So we switch it, so the external one is external, and then we have an internal token for in-between services communication, because it's a multi-tenant platform, and also to the end consumer communication. So even if you have hacked the external token, it will not be valid internally. That's how we do it, and can actually distinguish all customer information in all microservices. So it's important for us with these layers of security as well. Then we anonymize the traffic from the edge. It's not related to customers. It's also only an ID. So it's only when it combines the digital twin and the device that the business logic knows that we know the data sets that is actually relevant to present for each object. We work with event sourcing. We use Akka and Akka streams because we have written everything in Scala, the Scala language. And the Akka streams is then talking to one another. So all the microservices uses event sourcing between them. So they listen to events and see if it's applicable for me. So we have eventual consistency to be able to scale out a lot. And then we have the container infrastructure, and then of course the operating system. Use either Aurora, or if you run in AWS, or an own hosted Postgres. And then we have influx data that is time series data. So that's more low level than we can go further down as well, but I think you get an overview of what we do. Any questions? Yeah?
Okay, as far as I understand, this is centered around the sensor data and the inflow of the sensor data.
Yeah.
What's the corresponding diagram for the management of the far and tiny edge devices and download of firmware, updates, etc.?
Yeah, we have then microservices for that. We hold one microservice called Assetto, and that's for asset management. So business users can, via the portal, define their assets. And they can also, we have one other system called Gizmo. We have these short, funny names for everything. It's one architect that decides all the names. That's very important to stress. But in the Gizmo service, it's also doing configuration updates and gives topics to the far edge. So if when it connects, it listens, do we have another instruction? It could be a config, it could be a firmware update. If we do it with Rancher, we do it with Rancher instead, changing the container. But if it's on the tiny edge and the other, it's the here. And we also have the business user interfaces for doing business roles, like we call it an echo service for app push or email things. We have discovered this, so you can email this with a template. And we also have some analytics and KPI functionality. Actually, we're launching that in a couple of weeks, where we can aggregate events and make the business dashboard more like KPI driven, both from the whole stack, a group of assets with a group of sensors, or related to human interactions, because we also store humans and service interactions. I will show that from business users to a timeline. So we can see events, it's like a logbook. Okay, the AI discovered this event, it was a threshold from a sensor. Here the service technicians actually switched filters because they've done a manual thing. So everything is created and stored in timelines. So it's a lot of business user interfaces in the platform. Yeah, and actually I promised to do some live. That's very, we say one shot, one opportunity, we said yesterday. We traveled with this in my luggage, and I will show you a little bit. Maybe I need to reload. Yeah, but the package here, as you see, this is the version that is SUSE branded. So we can spin up a system where it's SUSE, and this is the Youmoni console. This is a little bit older, it's 5.0, but we have a 5.3, really reworked. But our thinking is that the business user should get an overview directly. So these objects are monitored, you can see the locations, and if they are green, there are no events, nothing to worry about. It's all okay. So then you can just relax and drill down. So some of our logistics companies, they have like a dashboard and then they use this mode to see all their trucks. If all are green, it's okay. If one becomes orange, maybe something is happening here. If it becomes red, something you need to act on. So you can drill down here. So if I just hover and press one, I can actually see, okay, this was the garage here. Okay, now I remember. It's all green, but it's okay. So you can drill down from the map, or you can go other places. So what we have is both a dashboard. We have location systems, so you can go through your whole organization with places or dealers. That's also possible to configure in the microservices and all presented in the platform. We have a facilities views. Here is the Jardine water treatment facility. It's actually a demo object that we used in Chicago. And the facility could be a couple of machines. Here is a pump station, so a truck that delivers the pumps. Here is a truck view. Of course, there is a notification view, possibly not a lot of notifications here right now. A device view. You had this device management question. Yeah, here I say the device view. And here's the Contron SLA Micro here in the demo. And you can actually see here that the system discovered when we hooked it in, it's very real time. A few seconds ago, I got data from its far edge. So that's how everything is aggregated. Listen to our event bus and sourcing. So it actually knows that this was a line. So I can either go via the business objects or the technical objects if I'm a technical guy. So if I press here on this device view, I actually go to the device view and metadata in the system to this device. And here I can see the system temperature in this device for the moment. And I don't have any, if it was connected to 4G or 5G, I would also have the signal strength from the mobile network here. So I get an overview, okay, it's good connectivity and it's a good system temperature. It actually works good, this device. So if I go to the sensor view, I press it here. I can see the sensors. It's actually the sensors here on the table here. You can see I started it before the presentation. And in here you can see the data, where it comes from. It also calculates, this is standard only, but it calculates a summary all the time, an average sensor summary. We have like an average machine oil level and stuff like that. And it's calculated in real time. I can also have a view of a heat map, see what sensors is communicating the most, to get an overview of the technology, which sensor doesn't work at all, and which sensor sense a lot. So that's also part of out of the box. So yeah, I can do maybe, here's ambient temperature, sense vibration. Do you think it will work? Maybe it feels my vibrations. This is the sense card. And actually here I also have the radar, so it actually can feel things in distance. Here is another distance sensor that senses things here. And when I do these things, it's first pre-processed here to see if it's everything that it should communicate or compress, and then processed in this computer, and then sent to the cloud. And these sets of graphs and so forth, if you talk about like administration, we can walk into this, but a partner or a customer get a lot of tools out of the box also in the platform. So you can actually either go on asset administration, that's one view. I will not walk through everything. A device administration view, and here you can see the device that is communicating, but here you can actually go into edit mode. You can also see the JSON objects that actually defines the device. And actually here really just manipulate the JSON object and make the whole cloud think differently about this device. If I go to configs, we are actually now also moving to the possibility to see all the graph configs within the platform. And actually I can see that it's very defined with JSON as well, so I can actually as a partner or a customer just modify the objects within the platform. Just save it, and in runtime it will change and it will be updated. So this is more the technical admin views, but if I don't, or more like a user, I can do more do user groups, roles, and like memberships and so forth within the platform as well. So yeah, we can do that. I will go back to this pump, I think. You can see here, I did this thing on the platform. So this is the vibration sensor. It actually senses what I did. So here is the point that it calculated, yeah, this new vibration should be sent to the cloud from the far edge. And it actually did that here in real time. So that's maybe one proof that it works after the traveling. But because it was real time, yeah, but that's how it's actually very fast processed and then communicated and then also presented in the platform.
Yeah, and then it helps with predictive maintenance of everything.
And as you saw, I could zoom in and I see the timestamps of all the things that is actually stored in the object. You can configure if you want it highlighted or not, but I've done it here. So I will go to information, and we talked about service requests before. Actually, we have a service, also service request flow, but a lot of things when they come to us, okay, now we monitor, it's great, now it's when something is wrong, what should we do? Yeah, then we have processes that also include humans. So here is also metadata about this pump. It can also have service manuals for the service technicians, so you can publish that to assets. So they have everything on the same place, both sensor data, service manuals, service requests. So what we have done here, I discovered that this screen size made it a little bit bad, so I will do this, I think, yeah. So the system generates also a unique code for everything. This code can be put on the like the pump station. This code is the digital twin of this pump. So I have a service app. This is a SUSE branded service app. So if I take this app, I scan the machine, I get all the data in my pocket from the cloud. So here I just scan it, get it to the cloud, and here I get the details. I get all the sensor values from the pump. But I can also, with one click, see instructions, service instructions. What should I do? And then it's just filtered for this object. And then it's very handy to make it easy for service technician. But I can also, in this case, actually put in a new thing that I cannot fix this, like and then make it an information. Maybe I want to take a new image, saying we need a new spare part, and then just save it. So if the service technician is doing this from the app, the system knows that I scanned this code. So if I go back to the service request, you can see that the service request from the field, from the edge, is now like processed into the cloud as well. So then the back office personnel can actually see that something has happened. You can also start a chat discussion with the service technician and so forth within the platform. So let's show a little bit of the possibilities and processes, and so how does other packages look like? Most of our customers, they start with our Youmoni cloud. It's a multi-tenant public cloud. And what we're doing with SUSE and discussing is that we will package an edge image of the SUSE Edge that can connect to the public cloud automatically, and you can test it. So you can actually run the edge computing, and then you have a tenant set up in the cloud. You have all these user interfaces, can test your sensors, your processes, to make it very easy to continue and test both IoT and edge to combine with the cloud. Then we have this template. So if the customer wants to move forward, or you as a customer want to move forward, you can spin up your private IoT cloud with SUSE infrastructure. And then both have the edge computing and the SUSE infrastructure. Use our cloud platform within that infrastructure, and then be very private with everything. It could be in an AWS template, it's what we've done now, but it could be others as well. But then also may have the possibility to actually have an enterprise license of everything, to actually move it on-prem and have your own stack, both with the infrastructure, with your other open source initiatives, and also run everything locally and monitor as you do today and want to do with your processes. So that's the path we're thinking of working with together, and that we talk a lot with customers with for the moment. But the path is quite good because it's easy and cheap to start in our public cloud. So there's no hassle to start an IoT project. You don't need to buy infrastructure or licenses or anything. It's just subscription. And for the trials, we make it for free. And then you can move on if you think it's good and if you see other business possibilities with it. Yeah, that's about it.
Yeah.
But you have some more?
Yeah, I have some more. I looked at the time to be cautious of time. I have like 3 minutes, so I'm going to talk very, very fast. What we're now talking with Youmoni, this was all created, built with SUSE Edge 2.0, but in April we launched SUSE Edge 3.0. And there are some important things which can help Youmoni, for example, have a standard image where they put all the components in and even can send it out to the hardware supplier, which put the image on the box and do a callback. So we have created in the Edge 3.0 platform a product called the Edge Image Builder, which will take a basic SliMicro image. You define into YAML code what you need. I need the K3S cluster. I need these extra packages installed. I need these applications to run on there. You just build it. You ship that image to your hardware vendor, and they can install them. When it gets online, it does a callback and configure the whole system. This can work in a connected way, but also in an offline way. So you have to do a little bit more in offline, of course, but you can package everything up and combine it. So that's a very powerful part of the new 3.0 stack. So we can work fully air-gapped. Of course, we also have the connected support. The elemental integration is in there, so you can do the OS management from Rancher. And we have the SUSE integration for certain use cases. We are now also working, and that's a tech preview in the middle, for an optimized noise vector for in the edge, because edge devices you don't have control of. You don't know what's happening there. Somebody can plug something in, so you can, of course, shut down USB ports and that kind of stuff. But still, you want to see if there's happening something at the edge that is not allowed. So we are working on a noise vector, or we already have something, but it's tech preview for at the edge. And SliMicro has all, the FIP certification. We have SE Linux on there, sys hardening, that kind of stuff, to even make, at least the operating system footprint and also the attack vectors of SliMicro as small as possible. So there, you cannot install, for example, GCC library parts to compile code on there. No, you should already have done it in your own environment and then ship the code that way. So we are also working with the ACRI, Industrial IoT Management. That is for service discovery of sensors. So what we can do is, and then dynamically load the pods that are for that sensor, load them on the Kubernetes cluster or the K3s. So you are very flexible. You don't have to need upfront what you're going to run on that host, but just connect the sensor. Acri will detect, oh, this is sensor XYZ. Okay, I'm going to load that pod that is needed for that sensor, and then it starts sending data. We have metal LB support now, so a load balancing type of thing. Well, not so really in your case, but if there's going to be in the future where Youmoni needs 2 devices or 2 of that, I forget your name, Contron box. So we can do now a 2 cluster setup. That's always a challenging stuff with who's the boss. So we're trying to or we're solving that with nets. We have a tech preview of Linkerd, so a service mesh basically. We're doing also the possibility, not engaged for this Youmoni, but if there's a customer that wants to do also run a virtual machine, we can do a lightweight virtualization stack at the edge right now. Don't think it of a complete replacement of any virtualization tool. It's just starting or configuring a virtual machine running there. You can stop, start it, open the console, and that's it. But probably you don't need more at the edge, basically. So we have the multi-visibility UI. So there are situations, or we have customers where they are running multiple Rancher installations, and we putting on top of that an umbrella where we can monitoring all those or get all the information from those various Rancher UIs. And most important, and a lot of customers are asking for that, we do stack validation. So we test end to end, and the results will be published online and that kind of stuff. So that is the most important stuff now for the SUSE Edge. So I'm gonna, well, this is the whole stack. Let it sink in. This is another visualization of what I just talked about. Yeah. Oh, you want to take pictures? Yeah, okay. Picture time. And next. Picture time. This is the white paper blog post of us working together with Youmoni. You can look it up, QR code, and see it yourself. And sorry, picture time. Sorry, I was too fast. I want everybody to have most of the time out of the lunch.
You can always search for Youmoni and SUSE IoT. I think
also on the internet, but that was the link directly to the blog post. There is this afternoon. There is a talk, the SUSE Edge roadmap that's done by the field PM, Reese Oxenham. Very interesting to see what we're even going to do more in the future. So this is what I showed, this is what we're doing now, and he's giving an overview of what we're going to do more with it. So thank you for listening. And have a great SUSE Con.